Good evening, and thanks for staying so long. So I'm a member of the Google Data API team, and I'll be talking about introducing you to Google Data APIs, and also in the process, getting you more familiarized with what it is about and how you can use it for your development purposes. I'm from New York, and so every time I travel to a new country, like one of the things which I found a little bit difficult to adjust to, or like take some time to adjust to, is like the currency. So whenever I catch a cab or a train, the first thing I notice, like I fumble around my coins, like, okay, so this is like really $2, this is like 20 cents or something like that. So when I look into that, actually, like we are looking at, okay, what if we have like a uniform way of interpreting it? Like by looking at it, I know like, okay, hey, it's a $2 or it's a 20 cents. And not like the bigger the coin, more the value is kind of thing. So speaking of which, uniformity. So Google Data API is like our primary goal is to, so you have been using Google for multiple purposes. Like one of the key things which have developed recently is like Google Apps. So you have like a lot of different applications like Spreadsheet, Calendar, and Google Base, etc. So Google Data API comes from the motivation to be able to share that information with you, with your applications which you develop outside of Google to interact with Google. For that to happen, for that to make it easier, actually, you need to have a consistent interface. So irrespective of like which application you are talking about, you need to have like, okay, irrespective of like these 10 applications, okay, if I can access application A this way, it's the same thing, same principles applies to B, C, and D. So which means it's easier to get adaptability with the developers. So Google Data APIs is all about like providing a consistent way of exposing Google information. Speaking of which, I would like to quote Mr. Jeremy Swerney. He's a MySQL guru with the Yahoo Platforms team. When he looked at GData for the first time, and he was talking about how we can manage semantic data in the web, either like getting the data or updating the data or querying a particular specific information. It's a much tougher problem. It's providing a consistent interface to do that is actually something which is not that easy. So he wasn't expecting to see it like anytime near soon, but GData is already, we are doing that for a wide range of Google services. Okay. What are we trying to achieve? So the first set of slides, I'll go through like a little bit of history on GData and why it was developed the way it is. And in the later part of the slides, we will go through specific examples of how we use GData, like what it means to use it against Google services. So two parts to it. The first part is actually to expose data store, which is stored within Google services. So as a user, you have your personal data stored in Google. Either it is like your blogs, or it's your calendar events, or your documents, etc. So you want to be able to access it programmatically from outside. The other part of it is we can't expect all the external developers from the same background, actually. So you have like different types of background, like you're coming from a specific programming language, Java, .NET, or C#, Python. Not only just that, but also you can be I'm primarily a desktop developer, or I'm primarily a web developer. So irrespective of where you're trying to access from, you should be able to access the information. So GData tries to solve the two problems. Like one is exposing on the server side, and also managing open source projects so that it's easier for you to develop your tools on top of those open source projects to access that information. Okay. So looking at the first part, exposing these data. So why is it difficult? Like, so when we looked at like different technologies, how we can do it, there are like tons of technologies which are developed over a period of 10 or 15 years in the past, primarily focusing on enabling services to talk to each other, or exposing interfaces for the services which are primarily data stores. Either it is like database to database, or like data format specifications like XML, or SOAP. A lot of you have used RPC, SOAP, XML combination to primarily like for exposing your legacy systems, etc. And also the recent development, which is a REST-based specification, a uniform way of accessing information in the web. So when we look at all of these technologies, like we jot down the basic requirements. So we want a simple data protocol. So when we talk about simple data protocol, it should be a data format which is easily understandable. And not only that, but also like, so when we talk about records or data in the web, we are talking about different entities. So we should be having a uniform way of addressing those entities. What's better than the way we address web pages? Web pages got really famous because there is a consistent way of identifying information. Everything is a HTTP URL. So you need to have a unique, consistent way of addressing resources in the data element, for the data elements. The other part is not only just get all the data, but also I want to have a way to filter that information. I want to be able to query for a specific information which I'm interested in. Not only that, once I get that information, what am I going to do with it? Either I can for presentation purposes, or also I want to, like, this is my personal information. I would want ability to modify that information and then store it back in the data store. So when we looked at all these requirements, so what fits well for our requirements? So out of the technologies which we investigated, the recent developments, Atom RSS-based syndication format, along with the Atom publishing protocol, kind of fit well with our requirements. So we kind of embraced these two technologies and built on top of these two technologies and extended it as GData API. So GData API is nothing but, it's an extension of the standards in the W3C consortium for Atom syndication format and Atom publishing protocol. On top of that, what we did was the syndication format defines the data format for your feeds, and the protocol specifies the communication mechanism of how you're going to interact with the system. This is basic HTTP-based get, put, delete, etc. On top of that, we built the Google extensions. The extensions are multi-part. You have to extend the data format primarily because you have some custom data which doesn't fit in the basic list of XML specification which is available with the Atom syndication format. Not only that, also you want to extend the query parameters. The other two key features are concurrency and authentication. When we talk about concurrency, it's more like a collaborative editing. You are like sharing a spreadsheet with your friend, and both of you are editing at the same time. So you want to have a consistent way of collaborating that editing efforts. So this is more to do with, in case of conflict, how to handle it kind of thing. Authentication, it's kind of like a little bit a specialized topic within, this is not part of the GData specification. GData uses a standard Google authentication mechanism. We will talk a little bit about like a couple of options available there. Okay. Let's talk about the extensions. So I guess all of you are familiar with the XML data format, namespaces, etc. Atom specifies its own namespace, Atom namespace. What Google Data, GData, what it has done is taken that namespace and also it added GD namespace. So all the common elements within which are created within the Google properties are part of the GD namespace. There are two pieces to these extensions, data model extensions. One is the basic elements. For example, let's consider a calendar event. So when we talk about a calendar event, you have information like what this event is for, and also like information like when this event starts from 4 p.m. to 5 p.m. and where it happens kind of thing. So the information about when and where, they are more specialized to this calendar event. So those are defined in the GD namespace. These are like individual elements which we call as types. And also there is kinds. So you can group those elements and provide a specialized meaning for that group of elements, what we call as kinds. So if it is a calendar, you have a group of elements which constitute the calendar event, which is a GD when element, where element, and also like do you want to send a reminder or those type of things. Speaking of kinds, Google Data has specified has standardized 3 kinds: contacts primarily for unique user contacts, events is for calendar events, messages primarily for like feedback to calendar events. Okay. The next couple of slides, we talk a little bit about like, there's a lot of XML. We don't need to focus too much into the XML. The idea here is to emphasize in an Atom feed which you get out of GData, there are two key pieces. One is the base core set of elements, and also you have the extensions. So this is a sample XML feed for a calendar event, which is for a, we are discussing something about integrating GData with a imaginary application. There are two parts to it. The first part, the core Atom elements. So you have the ID, published, updated, title, et cetera. These are coming from the core Atom specification. One of the key things which we like about these syndication formats is they require you to have a unique identifier for each of the data elements which you publish out there. So which kind of makes it easier for provide a consistent interface for identifying resources. The second part, what we have highlighted here are the elements which are defined by the GData namespace. So the when, where, what is the status of this event, whether it has been canceled or whether it's been confirmed, et cetera. The second line, we talk about like the kind. The reason for specifying these kinds or categories for each of the entries is, say, for example, as a vanilla processor, say, I'm a developer looking at a feed, which is just an XML document. When I'm processing it, when I'm looking at an event, I don't know what to expect. So there are like these are like self-description elements, which says, okay, hey, if it is an event kind, then I know like what to expect out of the entry. So there has been some debate going on, like whether we need to like use the category as a way to specify a self-description of the entry, but it's something which we have been going back and forth. Okay. So we looked at the data model. The next piece is querying a feed. Queries are, which you are familiar with, we have commonly used when we are like in our URIs. It can be very simple text query, or it can be a little bit more sophisticated on each of the properties. When we talk about text query, I can query for a friend by name John. Or it can be like a little bit more sophisticated, like say you have your photo album and you have tags associated with each of the photo albums. Like when you're blogging about this event, you're going to associate tags, GDD07AU. So you can search on those tags. Or like you can search more on the customized properties, like when it was last updated, or like say if it is like a spreadsheet, I want to know only the entries which are from row 10 to row 12. So in that case, I can say min row, max row kind of thing. Not only that, also GData provides the feeds in different formats, not just Atom format, which is the default. Also, you have a RSS format and also JSON format. So JSON is primarily for a JavaScript notation within your web browser. So if you want to fetch a feed within your web browser and present it within the web browser, so you can use JSON format. One key difference between these different formats are only Atom is read-writable. So you can fetch, read the information, and then you can make changes and post it back. With RSS and JSON, both are read-only. Okay. Let's look at the updates. When we talk about updates, three key types. So one is like I want to create a new entry. So I'm writing a blog about this event, so I want to create a new entry. So you can do a post to a feed link, which is part of the feed which you have gotten initially. You want to delete an entry. Say, for example, I don't like this feedback, which I gave earlier, so I want to retract it back. So you can delete the entry. And updating an entry. So updating an entry is you fetch this entry. OK, hey, this is the latest blog post for this event, and I want to change or put comments to add comments to that entry. Then you can add comments to that entry and then put it back. So all of these, the one commonality between all of these is each of them you don't need to like know exactly, okay, I have to get the service first, and then I have to inside of it identify a feed, and then inside of it identify an entry kind of thing. So each of the entries have their own Atom elements, which are called links within them, which uniquely identifies, okay, hey, where this information goes to. So you can use that information to post, delete, or put. So you don't need to have a complete reference of the history of that tree, hierarchy of where it is organized, how it is organized. Okay. Next piece is optimistic concurrency. This is with respect to collaborative editing. Say, for example, I have an event entry which two people are interested in. So both of them get the same version 1 of the entry, and then both are trying to make an edit, saying that, okay, hey, I'm not coming to the event. This guy says, I am coming to the event. And both of them trying to make an edit, and then when they try to submit, so the one request comes through first, and then the version is automatically updated to version 2. And then when the second request comes through, actually it was a modification of version 1, which is not the current version in the system, so which means it says, okay, hey, it is a conflict. So you have to fetch the latest version and make the change again. So this is actually a very Google-specific implementation. There has been some talks about using HTML tags, which is a much more standardized way of handling conflicts of sources within web-based CRUD operations, which is probably we might go towards the direction of tags, but right now the conflicts are handled by a built-in feature. So the last piece of the puzzle, security and authentication. Since all of your data is stored within Google services, so which means if you need to get that data, unless it is like published in a public form, you need to authenticate to the service. So depending upon what type of application you are using, say it can be a desktop-based application or it can be a web-based application. So if it is a desktop-based application, what you can do is you can ask the user to enter the username password within your application. So if it is a desktop application, then we assume that the user trusts that application to be secure. So the user enters a username and password, and your application is going to do a HTTP authentication request to the Google accounts, which is going to validate the username and the password and returns you back with an authenticated token. So in your subsequent HTTP exchanges, you're going to put an authorization header saying that, okay, hey, this is the token which I've got for this authenticated session. So then subsequent sessions can go on without any username, password information in the exchange. The other type of application, say I'm writing a JSP application, and I want to display this user's calendar in this third-party application. In which case, what happens is the third-party application has to redirect the authentication request to Google authentication service with a next link saying that, okay, hey, once you authenticate it, give back the control to me with a security token for this particular user. So the user is going to enter the username and password on the Google service page. So it's not going to be on the third-party site. And then once the Google gets that request, it looks at the application which is making that request, which is basically a proxy which is making the request, looks at it and they'll say, hey, is this guy is in list of authenticated applications, say registered applications. If you are registered applications, then automatically Google trusts a little bit, and then it won't give you any warning. If it is not a registered application, then it gives you a warning saying that, okay, hey, I don't really trust him. Do you trust him? So then if the user says yes, then we give the security token to the proxy application. So again, this is a very Google-specific authentication mechanism. And there has been some debate with respect to whether it is the right way, since it's a centralized authentication system. So far, it has worked well. So we have especially for calendar, we have seen about over 6 million hits a day with GData. So I think it's working well. So unless a big complaint comes through, we need to revisit. Okay. So putting all these pieces together, the next slides I would like to explain from a perspective of a calendar application, how do you use GData to do the create, retrieve, or update and delete operations. So say I want to create a calendar event. So this is a calendar event, lunch with Jill. And so this is starting on so-and-so date, and where is the event happens. All you need to do is create a XML HTTP request with the XML body, which says, okay, hey, this is the entry, lunch with Jill, and when it starts, where it happens. And you do a post to the unique URL for that particular user's calendar. So in this case, I'm adding it to Jack's calendar. So the URLs are also like very self-explanatory. So you have the base URL, which is within the Google space, and then you have like a unique ID, which is jack@gmail.com, and then additional parameters, which are more like visibility, like some specifics, which is specific to the application. So it's a very simple entry. So once you do that, you get a HTTP response back, says, OK, hey, 201 created. I have created this event. And this is the content of the event which I just created. If you notice, there is a new element I added to this XML blob, which is the identifier. So this identifier is auto-generated. So all the Atom specification requires you to have a unique identifier, and Google generates this identifier for you. So next time when you want to refer to this event to update it, then you just need a reference to this ID. So the identifier has one additional element, which says event ID, which is probably I think like a 32-character string. Okay. Now if I want to get a particular event, so what I'm going to do is I'm doing a get of the calendar feed URL. I'm getting a response back saying that, OK, it's a success, and this is the feed which I've got. So feed contains, general structure is you have a master feed, and then you have each of the events within the calendar is represented as entries within that feed. So in this case, we have one entry, which is corresponding to the event which we just created. And if I want to update an event, so I created an event. Now I want to change the place where it happens. So I have the identifier for that particular event. I create an entry with that ID, and then say, OK, hey, I am changing the GD where to Charlie's Cafe, so, and then post it to the URL for that particular event. And then automatically, you will get a response saying that, OK, I have updated. And then this is the new version of the event ID. And then it has been updated since the last time you created it. So it changes the updated timestamp as well. So there are a bunch of things which happens automatically, the fields elements which we don't control on the client side, but are controlled on the server side. So if I want to delete an event, I do a delete verb and give the URI of the event which I want to delete. Automatically get a response back saying that, OK, hey, the event has been deleted. Okay. So the reason I'm going through all of these individual samples is because irrespective of which service which you are using, either it is Blogger or like a Spreadsheet or Picasa, any of these services, the mechanism to add a new event or modify a new entry or modifying entry or updating an entry is the same. So you will go through the same basic four-step process, irrespective of which service you are using. So this slide explains a little bit about like how the URLs are built. This is more of an informational purpose only. So always you have, for a service, you have a base URL, and then within that you have an identifier. It can be a top level. There can be a multi-level identifier. In case of calendar, you have like an event ID identifier, and also a couple of other fields which have like special meaning within the context of calendar. Okay. So we talked about the core features of GData. So GData is a framework, so you won't see as a GData application, but you will see implementations of GData. So these are the services which implement GData and then expose their own APIs. So apps, base, Blogger, calendar, code search, notebook, Picasa web albums, spreadsheet. So the idea behind all of this is use GData as a consistent way of exposing information stored in each of those services. There are also a lot of other services which are in the pipeline. So eventually, hopefully, we can see all of the Google data can be exposed through GData. Okay. Not only on the server side, we also manage open source client libraries, which you see in the code.google.com space, in different languages. As I mentioned earlier, GData is basic XML HTTP. What these libraries do is provide an abstract object notation for those XML data so that you don't need to do your processing by yourself. And if you are working in a specific language and there is no library available, you can directly parse the XML response. You don't need to have a built-in library to do that. So that's the advantage of having a easily understandable data format. So Java, PHP, so Objective-C, it is an interesting story. Like one day somebody came and say, OK, why don't you guys have a Objective-C library? You don't like Mac? Or then he said, OK, I'll create one. So that's how it started. So a lot of these libraries are like efforts of individual people. So they wanted to access GData through the language which they are more comfortable with. So they built the building blocks for those libraries. Also, we have like some contributor libraries, Ruby, Perl, Lisp, are like completely open source, managed by external users. We have tons of documentation in code.google.com to get you started. And also, like our developer guides are pretty good in terms of giving you examples in each of the individual languages and the basic steps like authenticating and also like creating a simple entry, fetching the data, et cetera. You can pretty much copy-paste from the documentation. Also, we have a very active developer community and also a support group. So we have, like, I think, like 4 or 5 engineers in support group, constantly monitoring like what users want kind of thing and try to expose that type of information through the APIs. OK. The next 3 or 4 slides, I'll be about like different applications which use GData in the backend. These are like really cool applications. The first one, ambient clock. This is a iGoogle gadget. Just maps your daily events to an analog calendar, analog clock. The Picasa is like an online editing tool. It fetches the photos from the Picasa account for the user, and then you can edit it, and then it can save it back to the Picasa. So all happens with GData in the backend. Also, there are like time management, like timesheet logging tools, which uses a Spreadsheet API and Calendar API. Spanning sync is something Alan mentioned today morning. This is for Mac iCal integration. This is one of the heavily is more popular gadget application, which a lot of traffic, through which we are seeing a lot of traffic. Okay. Another cool application is mobile GCal. You can take your calendar in your mobile phone and then like create, delete, or event. This is not a sync application as the previous Mac-based iCal integration. This is more of like a front end for your Google Calendar, and this is like it's been like quite popular with a lot of mobile users. We have seen like a lot of traffic from this application as well. Okay. There are a couple more applications which are like, Gumio is like a very innovative concept because if you have a cell phone, pretty much you can place your ads for your, say for example, I have a car for sale or I have a pen for sale. You can pretty much place the ad from your mobile phone, and then automatically you can get a notification in your mobile phone if somebody makes a bid, or like you have put an alert saying that, okay, hey, I want to get an alert as soon as somebody puts an ad for this particular type of product or something like that. So this uses Google Base heavily in the backend for storing the information. So as soon as you want to place an ad, it automatically creates an entry in Google Base. And then it also uses a monitoring tool to constantly fetch the data and then send a notification. It's another virtual game. It's a web-based life where Bloghood is like a way to like enter blog entries to Blogspot from this game directly. Okay. So I would like to show you a quick demo of a mashup we created. This is based off a Java client library, which I built. So it uses the Spreadsheets data API, Calendar data API, and Google-based data API. Really cool thing is, like, once you are familiarized with GData, you can pretty much do whatever you want in terms of like, okay, translating information from one system to another system, or fetching information from different systems and presenting in your own presentation layer. So you can do anything you want. So here we have an event publisher event application. What it does is it takes a list of events which are stored in a Google spreadsheet, and then it publishes those events to Google Calendar and Google Base. So it adds those events to Google Calendar and Google Base, and then both of them will return back with a identifier for the entries which they have created, and then the ID is automatically updated in the spreadsheet saying that, okay, hey, this is the ID in Google Base for this particular event. Okay, with that, so I have a Tomcat server running in my local machine, and so this is the spreadsheet I was talking about. So I have like a list of developer events, which are listed like I just picked up from the Google Developer Calendar. And so this is a very simple application. So I'm going to, as a web application, I need to authenticate the user. So I have encoded the username and the password as part of this web application configuration. Now actually, I'm contacting the, so if you look at the previous screen, it's my local application. And I'm going to authenticate. When I try to authenticate, it redirects to the Google.com accounts. So the Google.com got the username and the password, and it identifies this application as a localhost event publisher. Hey, I don't really know about this application. Do you want to trust it? This uses the auth sub way of authentication. You can say grant access, and say automatically grants the security authorization token to my local application. Now I have like 2 spreadsheets for that particular user. One is called birthday calendar, or the Google conference events. So let me take the Google conference events. So 2007 developer events. So in a spreadsheet, you can have multiple worksheets. So these are the columns I was looking for, and these are the columns I found. So it's just automatically mapped already. So I'm going to publish the events. So these are the events which I read from the spreadsheet. Okay, so this is. So unfortunately, I went down the screen. Just a second. Okay. So I have 2 options. Either I can publish to calendar or base. So I'm going to publish to both. So when I hit publish, what it's going to do is it's going to send a put request to calendar and base, and automatically updates the URI for both the new entries which I've created in both calendar and base. Kind of a little slow. Bear with me. Okay, so now I see the calendar URLs and the base URLs for the entries which I've just created. So it's done, and I'm going to refresh my calendar. So I see the events in my calendar, and also I can see my items in Google Base. So developer day 2.0, etc. It's really cool because so when you use Google as a data store, it gives you the flexibility you want. Whatever you do through UI can be doable through the GData APIs. Okay. With that, in terms of like where we are at right now, most of the data format and the syndication format, like the app exchange protocol, are standardized. But there are still like a lot of features which need to be there. Like say, for example, like I'm talking about some type of automatic notification from my service. Like somebody creates a new event, how can I get an automatic notification? So those type of sync type of requirements are not there yet. And also, like right now, if you want to get a feed, you have to get a complete feed. There's no way of, like, say, do a partial update for the particular entries. So there are a lot of things which need to be done. You can go to code.google.com APIs GData to get more info and get you started with using one of our client libraries and then fetch this data. So the real power is actually you can publish this information anywhere you want. Either it is a web page or a Google gadget, or it can be anything. Even you can publish the information to like Maps, Google Maps. Okay, that's all I got. Thanks for coming here. Thank you.